LCR-T4 Mega328 transistor tester is one of the most versatile, essential workbench tools for homebrewers and electronics hobbies. Powered by the ATmega328P microcontroller, it automatically detects component types, maps pinouts, and measures critical parameters with a single button press. This is the zero insertion force or ZIF connector. You can see the pins 1, 2, 3 and 1, 1, 1. Once you insert anything here, this has to be used to make the connection. I'll show you. The 14-pin ZIF socket is internally divided into test nodes labeled 1, 2 and 3. Most boards have multiple slots wired to node 1, node 2 and node 3 to make inserting wide or irregular component leads easier. It does not matter which order you insert a 3-lead device like MOSFET or BJT across nodes 1, 2 and 3. The tester automatically identifies which pin is which on the graphic LCD. The tester identifies components across its pins 1, 2 and 3 of its ZIF zero insertion force socket and graphically displays their schematic symbol along with key electrical characteristics. A transistor has been placed in the ZIF connector. This is a transistor, and once it has been placed, you hold this and this lever is pressed in this direction. So this will close. And what you have to do is keep it in position, then press this button for testing. So it is testing an unknown or damaged part. Now it is showing correctly. This is a different transistor. You can see that it is showing the pinout, base, collector, emitter, and it is an NPN transistor. You can see the symbol here, and the HFE, that is beta. Amplification factor is shown here, 434. That's very good. For bipolar junction transistors, that is NPN and PNP, it will show the current gain HFE or beta, base emitter forward voltage BE, pinout mapping, base collector emitter, protection damper diode detection and forward voltage. For MOSFETs N channel and P channel, it will show the gate threshold voltage, gate capacitance, pinout mapping, that is gate drain source, intrinsic body diode detection and forward voltage. Junction FETs, pinout mapping, that is gate drain source, gate source voltage and drain current parameters. Next I am testing a diode. Here the symbol, direction, anode and cathode are shown. Then voltage, this is the voltage drop, 652 millivolt, and the capacitance. Diode has a small capacitance, 11 picofarad. Everything is nicely shown here. Diodes, triodes, SCR, forward voltage drop, junction capacitance, dual diode packages, common cathode anode, low power thyristors, tracks if gate trigger current is within GPIO limits. Another diode is being tested and it shows 647 voltage drop. This has been connected in the reverse direction. You can see the symbol has changed, and the capacitance is 13 picofarad. Now an LED is being tested. You can see the lighting up, and then the forward voltage is different, 2.03. The symbol is shown here, and the capacitance 2 picofarad is also shown there. Capacitors. Capacitance from 25 picofarad to 100,000 microfarads. ESR, that is equivalent series resistance for values more than 2 microfarads. Voltage loss percentage. A ceramic capacitor is being tested. It shows the symbol of the capacitor and its value is 2417 picofarad. Critical warning: never test a charged capacitor. Even a residual charge of a few volts can blow the 80 Mega328 piece ADC input pins, permanently damaging the meter. Always short capacitor leads through a low value resistor before inserting them into the ZIF socket. Capacitor is being tested. You can see it will take a longer time because it's a bigger capacitor, and the value is shown. Equivalent series resistance 0.46 ohms, loss percentage 2.9 voltage loss. Then this is 239.2 microfarad. That's the value of the capacitor. Now a larger filter capacitor is being tested. It will take longer time. So that is, you are seeing here 1032 microfarad. Equivalent series resistance is lesser, 0.30 ohms. Resistors and potentiometers. Resistance from 0.1 ohm to 50 mega ohms. Test two resistors simultaneously, ideal for potentiometers and dividers. Now I am testing a potentiometer. Interestingly, you can see this portion is shown as 26.78 kilo ohms and this portion is 27. That is in one particular position. Now testing in a different position. You can see when this has been changed in this direction, it is shown as a single resistor. 51.97 kilo ohm. Potentiometer position has been changed, you can see here. Now it is shown as two resistors, but the value have changed because I have changed the position of the potentiometer. This is a preset potentiometer, Hermet potentiometer. Now it is 16.84 this side and 36.90 this side. Inductors. Inductance from 0.01 millihenry to 20 henry. DC resistance of winding. I am testing a speaker. Speaker has two values. One is 4 ohms, that is the resistance, and 0.05 millihenry, that is the inductance of the coil inside the speaker. I am testing the inductance of the secondary winding of this transformer. This is transformer. It shows 2 ohm resistance and 269.5 millihenry, much higher as the inductance value. Resistance is quite low. It is the secondary winding of a step down transformer. This is the reverse side of the device. You can see the microcontroller here. Mega328P, it is shown here. I will zoom out and show you. Mega328P, and there is a crystal also. This is a crystal over here and several other components. So this is the reverse side of the tester, LCR tester reverse side. So the brain of that is the Mega328P microcontroller. Typically powered by a standard 9 volt battery or an external 8 volt to 12 volt DC source. The screen has an auto power off feature to conserve battery. Self-test and calibration. Short pins 1 and 2 and 3 together using a solid piece of wire. Press the test button to initiate self-calibration. When prompted on the screen to isolate probes or remove the short, remove the wire promptly. Optionally, insert a high quality film capacitor more than 100 nanofarad across pins 1 and 3 when prompted to complete offset calibration. Where it excels in RF and audio homebrewing, matching MOSFETs and transistors, perfect for screening and matching devices like IRF P150, IRF 510 or 2N2222, 2N3904 pairs for push-pull linear amplifiers or balanced mixers by comparing voltage, threshold, gate capacitance and HFE, that is gain. Checking unknown toroid or inductors. Quickly verify inductance values of hand-wound RF chokes or low-pass ladder filter coils without needing an RF bridge. Weeding out counterfeit silicon. Fake power transistors often show up as dual diodes or display abnormally low gate capacitance or gain compared to genuine datasheet specifications. Electrolytic health, that is ESR, equivalent series resistance. Spot dried out decoupling or filter capacitors in power supplies instantly by checking if the ESR has spiked above normal thresholds.